Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is a video, this video is part of the series of videos on concepts to remember. This is topic C on the chapter properties of triangle, where I will discuss about the key concepts on the exterior and interior opposite angles and the exterior angle property of a triangle. This video is part of the playlist CBSE Mathematics Class 7 following the textbook of author R.S. Agarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I highly suggest and request that you please support me by subscribing to my channel. And also please do not forget to press the bell icon so that you will be notified by my future videos. So, if you have not watched the topic A and B, where I discussed about the key concepts on the topics of properties of basics of triangles and the angle sum property, which are which are a part of the chapter properties of triangle, I highly suggest that you also watch the previous two videos, that is on topic A and topic B. So, in these kind of videos, these videos are inspired from the things to remember section in which is found in almost all Indian standard author textbook. The concept where in this series of videos I will point out, I will discuss the very key concepts from the chapter topic wise, and also every video, every topic will have a set of sample problems that you can solve to test your understanding of the key concepts of the topic. So let's get started with this video. Okay, so I have my rough notes on the key concepts that I will discuss for topic C, which is about the exterior and interior opposite angles and the exterior angle property. I hope you can see the notes on the left hand side, and on the right hand side I will do any kind of discussions required, even though I will not discuss in very much details, because I will just point out the key concepts, and wherever necessary I will do some discussion. Okay. So the first point, so I have listed all the concepts point wise, and I will discuss them one by one. Okay. So the first thing is about the exterior and interior opposite angles. So in a triangle, what do we mean by an exterior angle, and what are its interior opposite angles? So let's consider a triangle ABC. In triangle ABC, as you can see in the figure, two exterior angles, angle ACD and angle BCE, are formed at a vertex C. Now, in a triangle, exterior angle is always formed at a vertex, and two such exterior angles can be formed. In this figure, at vertex C, the two exterior angles ACD and BCE are formed. And how is it formed? It is formed by extending the two sides which have a common C as the vertex, that is the sides BC or AC. You can extend or produce the side BC to a point D, then you will create the exterior angle ACD, and if you extend the side AC to the point E, then you will create the exterior angle BCE. But these two angles are same, as angle ACD and angle BCE are vertically opposite angles. So this is the concept of how a exterior angle is created at a vertex. So always remember that an exterior angle is created at a vertex, and two such exterior angles can be created by extending the two sides which are having that vertex as the common point. Okay. So for C, you are having two exterior angles. Two exterior angles are being formed at vertex C. Similarly, you can have two exterior angle can be formed at vertex A and also at vertex B. Okay. Point number 2 is this is the main concept. This is the exterior angle property, which is that now in point 1. So what are the interior opposite angles? For every exterior angle is associated with two interior opposite angles. So when we have created the exterior angles ACD and BCE at the vertex C, what are the interior opposite angles? The interior opposite angles are angle A and angle B. So when you create an exterior angle at a vertex C, the two interior opposite angles are A and B. Similarly, when you create an exterior angle at vertex A, you will have the interior opposite angles B and C, and if you create an exterior angle at vertex B, you will have the interior opposite angles as A and C. Okay. Now point 2 says that the exterior angle is equal to the sum of the interior opposite angles. Now in this example, you can see that at vertex C, there is an exterior angle formed by extending the side BC to the point D. So we have this exterior angle ACD, which is marked as the angle which is having an angle y degree. So we will have, and its the two opposite interior angles are angle B and angle C. So we are having y degree equals to measure of angle A plus measure of angle B. Now measure of angle A means the actual value of the angle A in degrees. So we have so this is the angle exterior angle property. Okay. Point number 3 says that in a triangle there are total 6 exterior angles can be formed. That is 2 exterior angles per vertex. Let me show this. Let's say we have the triangle ABC. Let's say we are having this triangle ABC. It is saying, point number 3 says that there will be total 6 exterior angles can be formed. That is, we can draw total 6 exterior angles. That is 2 exterior angles per vertex. Now, so in the figure you can see that the total 6 exterior, there are total 6 exterior angles, but the similar colored exterior angles are same because they are vertically opposite angles. Now let's say I want to create an exterior angle at vertex C. So I can create 2 exterior angles. Let's say I am extending or producing the side BC. So I will produce the side BC like this to the point D. So this created the exterior angle ACD. Now I can also create an exterior angle at vertex C by extending the side AC. So if I extend the side AC or produce the side AC, it will be like this. Let's say I produce the side AC to point E. So at vertex C, 2 exterior angles got created, ACD and BCE. Let's say, so this is an angle. So this angle, let's say I am calling its value as X. So this will also be X as they are vertically opposite angles. Now let's see how we create an exterior angle at vertex A. At vertex A, an exterior angle can be formed either by producing the side BA or CA. So if I produce the side BA, then it will be and create produce the side BA, it will be like this. So I produce the side BA to the point say F, and if this created the exterior angle, this angle. This is the exterior angle that got created. Let's say this be Y. This is actually the angle FAC. Now I can also create an exterior angle at vertex A by producing the side CA. producing the side CA. Let's see. If I produce the side CA, it will be like this. So let's say I produce the side CA to point G. So this angle, this is the exterior angle got created, which will also be equal to Y. Now let's see how we create two exterior angles at the vertex B. So at vertex B, I can create an exterior angle by producing the side AB like this, producing the side AB to a point, let's say H, and this created the angle, exterior angle, this angle, let's say this be angle Z. Now I can also create an exterior angle at vertex B by producing the side CB like this. Let's say this point is I, and this created the exterior angle, this angle, and this will also be Z. So this is how we can create 6 exterior angles, total 6 exterior angles. Now the point number 4 says, out of total 6 exterior angles, there are 3 different exterior angles irrespective of their measures. Now actually there are 3 different exterior angles, and those 3 exterior angles, their values may be same or may be different. Now what are those 3 exterior angles? They are the X, Y and Z. So you can see that actually 3 distinct exterior angles have been formed, that is X, Y and Z. But also the X exterior angle, it has its vertically opposite angle, that is the BCE, which is also an exterior angle at the vertex C. But we are considering the unique exterior angles. So there are, in general, we say that there are 3 exterior angles in a triangle. So in this figure, we can say that X, Y, Z are the 3 exterior angles. Okay. Point number 5 says that in triangle ABC, the exterior angle Y degree formed at the vertex C is a linear pair to angle C. So whenever you, let's say, when we create an exterior angle at a vertex, let's say I have this triangle ABC. I have this triangle ABC, and I am creating an exterior angle at the vertex C by producing the side BC. It's like this. I produced the side BC to point D, and I got this exterior angle, this angle. Let's say this angle be Y degree. Now we have this angle A and angle B, angle A and angle B. Okay, now see that the exterior angle ACD was formed at the vertex C. Now since BC has been produced to D, BCD is a straight line. So the angle ACD and the angle C, they are adjacent and also lie on the same side of the straight line BD. This means that the angle ACD and angle C are a linear pair. This means that Y degree plus measure of angle C will be equal to 180 degree. This will be the case for all exterior angles. If you consider the exterior in the figure above, if you consider the exterior angle Y that is being created at the vertex A, then there also now in this case, let's say this be X, then it will make more sense. If we were to compare this figure with the above figure, then let's say this is X. So so for the exterior angle created at the vertex C, if its value is X degree, we say that we will have that X degree plus the angle C should be 180 degree, as they are linear pairs. Similarly, for the exterior angles formed at the vertex A, if its value is y degree, then we will have for the above figure we will have y, let's say this is y degree, plus measure of angle A equals to 180 degree. Similarly, for the exterior angle created at the vertex B, we will have z degree plus measure of angle B equals to 180 degree, as they are linear pair. So this is an important point. Okay. Point number 6 says that the sum of the three exterior angles of a triangle is 360 degree. So we just discussed that there are three exterior angles in a triangle, and the sum of those three exterior angles, the sum of the values, the sum of the measures of those three exterior angles is always 360 degree for any triangle. So in the figure, in the notes on the left hand side, you see a triangle ABC where we are having the external angles as P degree, Q degree and R degree. Then we will have P degree plus Q degree plus R degree equals to 360 degree. Okay. Point number 7. If a triangle has x degree, y degree and z degree as the measures of its three exterior angles, then its angles means that the angles of the triangle will be of measures 180 minus x degree, 180 minus y degree and 180 minus z degree. This is coming from the fact that we just discussed that when an exterior angle is formed at a vertex, let's say if the exterior angle is formed at vertex C, if the measure of that exterior angle is x degree, we see that they are the angle C and the exterior angle, they are linear pair. So we are having x degree plus measure of angle C is equal to 180 degree. So this implies that the measure of angle C, if we know x, that is the exterior angle formed at vertex C, then we can have the measure of the angle C as 180 degree minus x degree. This is 180 minus x. Hence, we have this point number 7. If a triangle has x degree, y degree and z degree as the measures of its three exterior angles, then the angles of the triangles will be 180 minus x degree, 180 minus y degree and 180 minus z degree, which means that the measure of the angle, where the exterior angle x degree is formed, the measure of that angle will be 180 minus x, and the measure of the angle of the triangle where the exterior angle y degree is formed, that angle will be 180 minus y, and similarly the angle of the triangle will be 180 minus z degree, where z degree is the measure of the exterior angle formed at that angle or at that vertex. I hope it's clear. Point number 8 says the measure of any exterior angle of a triangle lies between 0 degree and 180 degree. This means that for any triangle, depending on the angles of the three angles of the triangle, the the measures of the exterior angles will also vary. So whatever the angles, whatever the shape of the triangle, whatever the measures of its three angles are, irrespective of that, the measure of any exterior angle will always be greater than 0 degree and less than 180 degree. So in the figure, you can see that if the P degree, Q degree and R degree are the exterior angles, then we will always have P should lie between 0 and 180, that is P will be greater than 0 and less than 180. Similarly, Q and R will also be greater than 0 and less than 180. So we never have an exterior angle equal to 0 degree or 180 degree, because if an exterior angle, just imagine, if an exterior angle is 180 degree, that means that let's say we have now let's say we have a triangle ABC, a triangle ABC. We are producing the side BC to D. So this is the exterior angle. This is the exterior angle. Now, what will happen? What under what condition this exterior angle will become 180? So this angle, the angle C has to shrink. The angle C has to be very smaller, and smaller. Only then the angle, this angle, x degree, that is the exterior angle, will become more and more and more. It will approach towards 180 degree. Now, the moment this x degree becomes 180 degree, the angle C is becoming 0. And we know that in any triangle, all the angles are greater than 0. This is the reason an exterior angle is never a 180 degree. It always is greater than 0 degree and it is less than 180 degree. Okay, but I think I am missing few points. I'm missing few points. I wrote it down, but I forgot to export as a PDF. So we know that let's say PQR, let's say P degree, Q degree, and R degree are the exterior angles. Are exterior angles. Exterior angles of a triangle. Now we will always, it will be the fact that okay, so the point is a triangle will never have all the three exterior angles greater than 120 degree, and also a triangle will never have all its exterior angles less than 120 degree. This is similar to the fact that a triangle will never have all its angles greater than 60 degree, and a triangle will never have all its angles less than 60 degree. Now how for a triangle, for the angles of a triangle, why this 60 degree is coming, why 60 is coming, and for the exterior angles why 120 is coming. Now you can see that the concept is nothing but we have three exterior angles, and the sum of the, we know that P plus Q plus R, if P degree, P degree, Q degree and R degree are the measures of the exterior angles of a triangle, we know that P plus Q plus R will be equal to 360. So this implies this is an algebraic result. You can say that this implies that since there are three quantities, and the sum of the three quantities, that is P plus Q plus R, has to be always 360 degree, we can never have P greater than 360 divided by 360 divided by 3. Why 3? Because there are three quantities P, Q, R, and since their sum is always fixed 360, we can never have all P and the values of all P and Q greater than 360 degree, and also we can never have all the values of P, Q and R less than 360 degree. This is the scenario for exterior angles, and for the angles of a triangle, we have discussed that if the angles are, let's say, x degree, y degree and z degree, then we know that x plus y plus z equals to 180 degree. So 180, we know that the angle, sum of the angles of a triangle is 180 degree, so x plus y plus z will be 180. So in that scenario also, the values of x and y all cannot be greater than 180 by 3. 180 by 3, since there are three quantities. Similarly, x, y, z, all of them cannot be less than 180 by 3 because their sum has to be fixed. Their sum is fixed for the angles of a triangle. Their sum is 180 degree, and for the exterior angles of a triangle, their sum is fixed, which is 360 degree. That is the reason we say that a triangle cannot have all exterior angles greater than 360 by 3, which is 120 degree, and a triangle cannot have an exterior angles whose all exterior angles whose values are less than 120 degree. So these are all the concepts that I wanted to discuss. And based on these concepts, I have prepared some sample problems. The PDF of the sample the link of the PDF of the sample problems I will attach in the description below. You can check that out. And I hope this video was beneficial. This series of videos on the concepts to remember, I'm trying to mention the key points and key concepts so that you can use these videos as a checklist once you have completed the chapter and once you have solved quite a bit of problems from your textbook or any other reference books. If you see these videos, then you can evaluate that you are well aware of all the key concepts, and if you can solve the sample problems, then it will also give you a good evaluation of your understanding. So if this video was useful, then please like it, share it with your friends, and also once again please support me by subscribing to my channel, and please do not forget to press the bell icon so that you will be notified by my future videos. The next topic, the topic C, I will discuss the triangle inequality and Pythagoras theorem. So please stay tuned for the next topic, topic C, topic D, which will be the last topic on the chapter properties of triangles. So thanks for watching, and until the next video, take care and bye.